In this video, we will talk about thermodynamics, which tells us whether a chemical or physical change will happen in a given direction. If it happens, we call it as thermodynamically favorable or spontaneous. If it is not going to happen, we will say it is not thermodynamically favorable or non-spontaneous. So, spontaneous doesn't mean that it is happening all of a sudden or it is fast. It just means that it's going to happen. It can be either fast or slow. So if it is thermodynamically favorable, that proceeds without an outside assistance. Say, for example, think about melting of ice. Just by putting outside at room temperature, the ice cube will melt. So that is a spontaneous or that is a thermodynamically favorable change. So to understand whether a given process is thermodynamically favorable or not, we should be familiar with the two terms. That depends on two terms. In other words, they are entropy, which is represented by the letter S, and enthalpy, which is represented by the letter H, which we already learned, enthalpy change or heat exchange or heat change delta H. So heat exchange happens or transferred from a system to the surrounding or surrounding to the system. And we call that one as first law of thermodynamics, which means energy cannot be created nor destroyed, or the total energy of the universe is constant. Entropy is a measure of molecular randomness. So that means it's a measure of disorder in a system. Another way to think of entropy is that it describes how spread out a system's energy is. Say, for example, here we have solid ice, liquid water, and gaseous water vapor. We can see that energy is more in the case of gaseous water vapor. So we say that the entropy of the vapor phase is higher than the liquid phase, and the entropy of liquid phase is higher than the solid phase. So entropy increase means we say it in a positive entropy. So the positive entropy for gas and positive entropy for changing from solid to liquid. And if it is moving from gas to liquid, it is negative entropy. And if it is moving from liquid to solid, again, we can say that entropy decreases or negative entropy. Here are some other examples where entropy changes when the phase changes. Say, for example, in the first case, iodine vapor condenses on a cooled surface to form crystals. That means the energy is decreasing because it is gaseous phase changing to solid phase. That means energy is decreasing and the randomness decreases. That means disorder decreases. In solid state, it will be more orderly arranged. So we can say that entropy decreases. So that means it is going to be negative entropy. And evaporation of alcohol. Alcohol, liquid phase changing to gaseous phase. That means more disorder. So entropy increases. So it will have positive entropy. The freezing of water, that means liquid phase changing to solid phase. Again, as in the first case, the disorder decreases. That means also energy decreases. That means it will have more orderly arrangement. So what happened to the entropy is entropy decreases. So we can say entropy is negative in that phase change from freezing of water. Similarly, entropy usually increases when solutions are formed. Say, for example, solid salt is added to water to form a solution. What happens? The solid salt will have orderly arrangement. When it is in water, it will dissociate into ions, sodium ions and chloride ions, and more randomness for those particles. So the entropy increases. So it will have positive entropy whenever something is dissolved in water, sugar dissolved in water or salt dissolved in water. So the randomness increases, so it will have positive entropy. An increase in entropy is also noticed when more gaseous particles are formed. Say, for example, the dissociation of water, here we are getting 2 hydrogen and 1 oxygen. So we can see that 2 gaseous particles in the reactant side changes to 3 gaseous particles in the product side. So in this case, we have positive entropy, or we can say the entropy increases. Another way to increase the entropy is by increasing the temperature within a phase. Say, for example, if you heat up water, liquid water, the water molecule gain energy and the randomness increases or the disorder increases. So in that case, entropy will be positive, or we can say that entropy is increasing. So in a spontaneous process, the entropy is always increasing. So that means entropy of the universe increases even though the energy of the total energy of the universe is always constant. So this increase in entropy of the universe is called second law of thermodynamics. So for a system at equilibrium and for an exothermic process, the entropy and enthalpy, we can connect them using the formula delta S, that is change in entropy, equal negative because it is exothermic, delta H, that is change in enthalpy, divided by the temperature at which the change occurs. So the unit will be for delta H, that's the energy unit, right? So joules, it can be kilojoules. If it is kilojoules, we can convert it into joules, and vice versa, whichever is required as per the equation. So delta H is in joules here, divided by the unit of temperature is Kelvin, and that is for 1 mole. So joules per Kelvin mole. Let's see an example. In the metallurgy of antimony, the pure metal is recovered via different reactions depending on the composition of the ore. For example, iron is used to reduce antimony in sulfide ores. So we have an equation with the delta H value given, which is negative 125 kilojoules. So we have to calculate what? We have to calculate the entropy. So since we have to connect delta H and delta S, we can use the formula delta S equal negative delta H over temperature. So we have delta H value given negative 125 kilojoules. Either I can convert that kilojoules to joules and write the answer in joules, or I can leave it like that and I can answer the question in kilojoules. Okay, so the temperature I have to convert it into Kelvin, 25 degrees Celsius. We can convert it into Kelvin and we will get 298 Kelvin. So when you plug it in the calculator, it will be 0.419. The unit will be kilojoules per Kelvin mole reaction. And also we can write in terms of kilojoules convert to joules, correct? That means it multiplied by 1000, so 419 joules slash Kelvin mole reaction. And now calculate the delta S surrounding for the reaction below, and note that this is an endothermic reaction, so delta S equal delta H over T. Okay, and you should get an answer negative 2610 joules per Kelvin mole reaction. Like in change in enthalpy, we have learned delta H equal delta H of product minus delta H of reactant. We can do delta S as well, that is change in entropy. We can write entropy of products minus entropy of reactants. That means if we have standard values are given for reactants and products, we can write the delta S of, that is the change in entropy of the reaction. We can find by taking the sum of entropies of the products minus the sum of entropies of the reactants. Since the values are standard values, we have to show 0 on S. So delta S0 reaction equals sigma of delta S0 of product minus sigma of delta S0 of reactants. And now let us see an example. Given the following standard molar entropies, calculate delta S for the reaction. So 2Al solid plus 3 magnesium oxide solid gives 3 magnesium solid plus Al2O3 solid. So all the standard values are given. So let's go ahead and substitute in the formula. We know the formula for the delta S of reaction equal delta S reaction equal sigma of S products minus sigma of S reactants. So either we can calculate the products and reactants separate and then subtract, or we can directly substitute in the formula and we can find the answer. So I'm going to directly substitute here. So what are the products? Magnesium. I have magnesium here and I have 3 of them. So I will just multiply by that value by 3. And I have aluminum oxide and I have only 1 of them. So this is also one of my product. So 33 times 3. I will add that one with the 51 and then subtract. The reactants are 2 aluminum. So I have to multiply the value by 2. That means 28 times 2 plus I have one more reactant which is magnesium oxide. So I have 3 of them. So multiply that value by 3. So 27 times 3. And then we can simplify. That will be 99 plus 51 minus, I will have 56 plus 81, right? Okay, that's equal 150 minus 137, that equals 13.0 joules per Kelvin mole reaction. And now try this question by yourself, and you should get negative 188.3 joules per Kelvin mole reaction.